Okay, now in this function I'm going to take another function. I'm going to talk about the, okay, I have taken the function y equals to x square, or either you can write f of x equals to x square. Okay, I'm going to see the pattern of the graph, how it is going to be the graph for this function. So I need to prepare a table. I need to choose value for x from my side, and y value for those x I need to calculate. So x value I am going to choose over here 0, -1, -2 and 1 and 2. For these x value I have chosen, on these x value I need to calculate the value of y, which I am going to write over here. So when you plug in 0, 0 square means 0. When you plug in 1, 1 square means 1 times 1, 1. When you plug in 2, 2 square, 2 into 2, 4. When you plug in -1 square, -1 square means -1 times -1, that is going to be +1. -2 square, -2 into -2, so that is going to be +4. Now I am going to plot the graph of this function. So roughly I am going to do, this is going to be your 0, 0. Okay, this is on x-axis I need the values -2 and 2. So 1, okay, 1 and 2 I am going to take till 3, still I am not needed, -1 and -2. Okay, on y-axis I need 4, +4 only, 1, 2, 3 and 4. Okay, now first ordered pair is 0, 0, that I have marked. This is the point 0, 0. Now the second is 1, 1. X value is 1, then y is also 1. So when you go parallel to this, this is going to be the intersection point. This is 1, 1. Now second on 2, 4. So on x2, then y is 4. So I need to go parallel to this and parallel to this. So this is going to be to the point 4. This is 2, 4. Similarly for this side, -1, 1. On x is -1, on that y is 1. So this point. Okay, -2, 4. When you go this -2, this is going to be the 4. When you join these points, okay, I'm going to join these points. Okay, this type of pattern of the graph I am getting, this type of pattern, here the equation is quadratic because the highest power is 2. So this is a function, this is a graph of for this particular function, but it's a quadratic, and quadratic function always be a parabola. This shape is called parabola. Okay, this shape is called parabola. Either the parabola could be open upward, or maybe sometime you see that like this, or maybe this side or this side. So different pattern of parabolas you will be seeing, and this is the graph for this particular function. So okay, here what you can observe, on 2 it is returning 4, on -1 it is returning 1, on -2 it is returning 4. So on -2 and +2 it is returning the same y value. On -1 it is returning 1, on +1 it is returning 1. So on different x it is returning the same value. Okay, so when x values are different but y values we are getting same, in that case also it could be a function. Why it could be a function? Because this direction we are moving, then we are getting the value different, correct? When we are moving in this direction, then we are getting 4. On -2 we are getting 4 over here, on +2 we are getting 4. So y value could be different, y values could be same, but the x values are different. So for two different x we can get the same value of y. So here suppose if I make this mapping over here, I am going to write domain. Domain means the value of x. So x values -2, -1, 0, 1 and 2, and range. I'm going to range. Range is a collection of the second point of each ordered pair, means this y value. So that is going to be the 4, 1, 0, 1 and 4. Now I need to map. So this is going to, on negative 2 we are getting 4, on on 2 also we are getting 4, on negative 1 also we are getting 1, and on positive 1 also we are getting 4, correct, and on 0 we are getting 0. So what you can see, on two different x we are getting the same value of y. So for being a function, first domain, every value should have the image, means every value of x should return the y value, first point. Second point, for different x it can have the same y value. If this case is existing, for every value of x it should return a value, first point. Second point, for two different x it can have the same value, like over here negative 2 and 2 it is getting 4. So if this case exists, for different two x values it is getting the same value, then also it would be a function. So in this case also it is a function. If I say for that domain, what is the domain? Domain is going to be, for this case, if I write domain for this function is going to be negative 2, negative 1, 0, 1 and 2, and the range is going to be, this function limit is over here 0, 1 and 4. This function is lying over here, range maximum value is 4 and the minimum value is 0, and domain minimum value is negative 2 and the maximum value we have taken 2. We can move further. If we are moving further more x values, this graph will be like this, will go on, will continue over here, will go like this. Okay, so for the different x it could have the same value, but one value will be this side and one value will be for this side, so it is not going to be the coincide. Okay, it is going to be on the different side. So this is one kind of pattern of question we have seen for the function, and we have seen the domain, we have seen the range. These are the ordered pair and collection of ordered pair, 1, 2, 3, 4, 5. Okay, now one more thing I will explain over here. Like suppose here, like I'll keep explaining so it will be clear for you. Like over here I'm going to plot again it. This is 0, 0 and this is 1, this is 2, this is 3 and this is negative 1, this is negative 2 and this is negative 3. On y negative I was not needed, so 1, this is 2, this is 3 and this is 4. Again I am going to plot. On 0 we got 0, on 1 I got 1, so this is going to be the point, 1 point. On 2 I got 4, so that is going to be the point over here. Okay, this is the point. Okay, now on negative 2 I got, on negative 1 I got, this is the point. Okay, this is the point. On negative 2 I got, like over here, vertical line I have plotted. I am going to plot the graph for this. So when you plot, it is going to be like this. Okay, now suppose for example you have given this function is given, okay, and the question is asked, and over here on the graph, over here the dot is given on this point. On this point solid circle is there. Okay, solid circle is there, and the question is check. Question is find the range of this function. Range of this function. What is range? Range is the value of y. Means we need to see when this graph is limited up to this graph could be extended in this direction more, in upward direction it could be extended, but we have calculated for these fixed value. Got it? We have calculated for these fixed value. So this graph is also part. This is not the full graph. This is a part of the graph. Okay, and now over here these are the solid line. Over here the function we are, the graph is being fixed up. Okay, now I need to calculate the range of this function. So from where the y, it is minimum value. Minimum y value is, what is minimum y? 0. And the maximum where, till where we are going? 4. So for this function the range is 4, maximum 4. Okay, what is the domain for this function? So for the maximum y we need to check the maximum y and the minimum minimum x and minimum y. So on x-axis, what is the, on x-axis we can see what is the minimum and maximum value. That is going to be the domain. So the domain is like from minimum 2 to 2. Okay, and the range is going up to the 4. Got it? Okay, we see more example in the next video.